First law of thermodynamics. It is a fact which you need to know. Option C is correct, that is for a cyclic process Q is equal to minus W. Potassium is lighter than sodium. Why? Because there is a sudden increase in the size and we know that density is mass by volume. Volume suddenly increases, so density will decrease. Hello my dear students, I am Priyanka Rajaram from Vidhyaashram PU College, Temple of Excellence. Today I shall solve Karnataka CET 2010 question paper for you all. So we'll see the first question. In the electrolytic refining of zinc, option A, the impure metal is at cathode. Option B, graphite is at anode. Option C, acidified zinc sulfate is the electrolyte and the metal ion gets reduced at anode. So what is the question? The question is on electrolytic refining of zinc. So in electrolytic refining, cathode and anode what we use? Anode is the impure metal and cathode will be the pure metal, isn't it? So if we are using, here it is as it is for zinc, anode will be impure metal, that is zinc, and cathode will be pure zinc, and electrolyte will be zinc sulfate solution, isn't it? Now here what happens? Zinc ions will accept 2 electrons and get deposited at cathode as zinc. So we'll see the options which is right. First, the impure metal is at cathode, that is wrong. So this cannot be the correct answer. Graphite is at anode. We are not using graphite electrode at all. Option C, acidified zinc sulfate is an electrolyte. This is the correct one. The metal ions get reduced at anode. At anode, reduction is not taking place. So this is also the wrong answer. So the correct answer is acidified zinc sulfate is the electrolyte which is used. Okay. So we'll see the next question. The wave number of the spectral lines in the emission spectrum of hydrogen will be equal to 8 by 9 times the Rydberg's constant. If the electron jumps from option A, n is equal to 10 to n is equal to 1, n is equal to 3 to n is equal to 1, n is equal to 2 to n is equal to 1, option D, n is equal to 9 to n is equal to 1. So what is the question they have asked? The wave number of the spectral line in the emission spectrum of hydrogen will be equal to 8 by 9 times of Rydberg's constant if the electron jumps from. So first the wave number, what is the formula? RH 1 by n1 square minus 1 by n2 square. Correct? Now they are telling that the wave number is 8 by 9 times the Rydberg's constant. So if I have to get 8 by 9 times the Rydberg's constant, what should be n1 and what should be n2 is what we need to know. So if we see, 9 should come as a denominator which is common for both after squaring. Which is the possible values after squaring to get 9? It should be 3. So which is the option which has 3? Option B. So I can directly tell option B is the correct answer. But then if you want me to solve it, I can do it. Okay, so n1 will be 1 square minus 1 by 3 square. So 8 by 9 RH. So RH is equal to, I can get this as 1 minus 1 by 9. Isn't it? Correct? So if I take the common denominator 9, it will be 9 minus 1, 8 by 9 RH. So N2 is 3 and N1 is 1. Okay. So we can do this way. or you can keep n1 square and n2 square as it is, and you can substitute, as you can see in all the options, n1 is 1. Option A, option B, option C, as well as option D. So you can replace n1 with 1, and then you can find out n2 by equating it to 8 by 9 RH. So there are multiple methods of solving this, but without even writing, we can solve this just by knowing that the denominator should be 9. That means the square of the number should be 9, and square of the number which is equal to 9, which is possible here, is only 3. Isn't it? So that is how I told B is the correct answer even without solving. Okay. So we'll see the next question. Question number 3. Consider the following gaseous equilibria with equilibrium constant K1 and K2 respectively. The equilibrium constant are related as. Okay. Now they have given 2 equations. I am not reading the options now. Okay. Directly we can solve and we can come into conclusion. Okay. That way it is actually easier. That's the reason I am telling we will just do it off. So first equation and second equation, if you see, what you understand is, if I take the first equation, multiply into 2 and then reverse it, I'll get the second equation. Am I right? So what I am doing, first I am multiplying by 2. So this I am going to multiply by 2. So K1 will become square. Correct? The constant K1 we have to square when you are multiplying the entire equation into 2. Then this is K2. For the second equation, the equilibrium constant is K2. Now I'll reverse the first equation. So it will become 2SO3 gas reversible 2SO2 plus O2. Okay. So when I reverse K1 square, what it will become? 1 by K1 square. Correct? No? When we reverse, it will become reciprocal. Correct? So now if you see equation 2 and this what I have written is equal. Same it is. So I can write it as K2 is equal to 1 by K1 square. Or I can just write it as K1 square is equal to 1 by K2. Now we'll see which of these options are there here. Okay. Option A, 2K1 is equal to K2 square. No, it cannot be. K1 square is equal to 1 by K2. This is right. K2 square is not possible, is equal to 1 by K1. K2 is equal to 2 by K1 square is wrong. So we have got the answer. It is K1 square is equal to 1 by K2. Here we have got it. Isn't it? Correct? So this is how we have come to this answer. Fine? Shall we move on? Next question. Enthalpy of vaporization of benzene is plus 35.3 kilojoule per mole at its boiling point of 80 degrees Celsius. The entropy change in the transition of the vapor to the liquid at its boiling point is, it's given in joule per Kelvin. I want the answer in joule per Kelvin. Okay. We'll just see the answers or the option. Option A minus 100. Option B minus 441. Option C plus 100. Option D plus 441. So you will get the answer plus or minus 100 or 441. But see, the transition is from vapor to the liquid state. From vapor to the liquid state, what do we call it as? Condensation. Isn't it? So delta S condensation. So it is from vapor to the liquid state. Entropy is decreasing. Isn't it? So it will be a negative sign. Yes or no? From the vapor to the liquid state, it will be negative sign. I'll just put off the negative sign here. Delta H condensation by TB. Okay. So what is the delta H value? It is 35.3 kilo S 10 to the power 3 joule per mole. Why I have converted into joule per mole? Because I want the answer in joule per mole divided by temperature I want in Kelvin. Okay. Because here also see it's in Kelvin. Okay. So 80 degrees Celsius is how much Kelvin? So TB is equal to 80 plus 273. That is 353. correct? So divide by 353. So I will move one more point. It will be 1 into 10 to the power 4. Here I'll move one more point. It will be 10 to the power 2 and 353 by 353 into 10 to the power 2 joule per mole here, and it is here Kelvin. Okay, so this gets cancelled. So it is negative sign we have forgotten. So 100 joule per Kelvin is the answer. So it is minus 100. Option A is the right answer. Okay. So question number 5. Which one of the following conversions involve change in both hybridization and shape? Option A, NH3 to NH4 plus. Option B, CH4 to C2H6. Option C, H2O to H3O plus. Option D, BF3 to BF4 minus. So what are they asking? They are asking us which one of the following involves change in both hybridization as well as shape. So both has to change. First thing is, if you see NH3 to NH4 plus, both are sp3 hybridized, but shape is same, changed. That is, here it is pyramidal due to presence of a lone pair. Here it is tetrahedral. Same way, H2O also, H2O to H3O plus, the number of lone pair of electrons differ. So both hybridization still remains sp3, as there is lone pair of electron, it can take up H plus ion, but the shape will change from bent to pyramidal. So both of this is ruled out. Option B, if you see, this is sp3 hybridization, this also is sp3 hybridization, and both are having tetrahedral structure. So again, you cannot tell it is option B. So it should be option D, which is BF3 to BF4 minus, where BF3 is sp2 hybridized, whereas BF4 minus is sp3 hybridized. Okay, thus option D, B, hybridization also is changed. Of course, the shape also will change. Okay, thus option D is the right answer. We'll see the next question. In chromite ore, the oxidation number of iron and chromium are respectively +3 and +6, +3 and +2, +2 and +3, +2 and +6. Chromite ore contains FeOCr2O3, or we will write it as FeCr2O4 also, we can write it as, but in this you know x plus minus 2 is equal to 0, x is equal to +2. So for iron it is +2 state. For chromium, if I calculate, it is 2x minus 6 is equal to 0. So x I will get it as +3. Isn't it? So it is +2 and +3. So which is the correct option? It is option C. +2 for iron, +3 for chromium. Okay. We shall see the next question. For the reversible reaction A plus B giving C plus D, delta G0 is equal to minus 350 kilojoules. Which one of the following statement is true? Equilibrium constant is greater than 1. Option B, entropy change is negative. Option C, the reaction is thermodynamically not feasible. Option D, the reaction should be instantaneous. So, it's a reversible reaction is given. And which one of the following statement is true, they are asking. That means which is correct is what we have to find out. Correct? Yaud sari anta na will helbeku. But what do you get from looking into the question? First thing you see, a solid also is getting converted into a gas. So randomness is increasing. Randomness jasti adre, what will happen to the delta S value? Delta S value also should be more. Jasti agbeku. Negative irutta? Illa. So option B, tappu. Entropy change is not negative. because randomness is increasing here. Okay. Then the reaction is thermodynamically not feasible. If it is not feasible, delta G naught value wouldn't have got. It's a spontaneous reaction. So this statement is also wrong. The reaction should be instantaneous. Idu reversible reaction, instantaneous agakagalla. So it is not a reaction which has to be instantaneous because it's a reversible reaction. So even this is wrong. Obviously then option A should be the correct one. That is, equilibrium constant is greater than 1. Yes, of course, because delta G naught is equal to minus 2.303 RT log K. So this value is also negative. 350 kilojoules is equal to minus 2.303 RT log K. So both are negative value. It will get cancelled and equilibrium constant will get a positive value which is greater than 1. Correct, no? Thus, option A is the right answer. Okay. We'll see the next question. Out of the below two compounds, the vapor pressure of B at a particular temperature is lower than that of A, higher than that of A, same as that of A, higher or lower than A depending on the size of the vessel. So here the vapor pressure of two, A and B, it is compared. B is compared to that of A, whether it is higher, lower or same, or it depends on the size of the vessel. So if you observe B, what is this? Orthonitrophenol. In orthonitrophenol, there is an intramolecular hydrogen bonding. Correct? So when there is an intramolecular hydrogen bonding, then what happens? The molecule will be more volatile, or this compound is more volatile. Whereas here you have paranitrophenol. Paranitrophenol, if you see, this one more molecule and here there will be hydrogen bonding. Of course, hydrogen bonding I should show clearly. Okay. So there will be hydrogen bonding. NO2 group is there. So intermolecular hydrogen bonding will be there. This is less volatile. So what you can tell, the vapor pressure of B will be more than that of A because it's more volatile, its vapor pressure will be more. Correct, Alva? Yes or no? So what is the answer? Vapor pressure of B will be more than that of A. It's not lower, it is higher than that of A. Option B is the right answer. So I hope you have understood. We shall move to the next question. The amount of heat evolved when 500 cm cube of 0.1 molar HCl is mixed with 200 cm cube of 0.2 molar NaOH is 1.292 kilojoules, 2.292 kilojoules, 3.392 kilojoules, 0.292 kilojoules. So you have to calculate what is the amount of heat evolved, that is heat of neutralization of an acid with a base, that is with HCl and NaOH. We know that 1 mole of HCl, when it is neutralizing 1 mole of NaOH, the amount of heat liberated is 57.3 kilojoules. So we have to know this, or it's there, it's a fact that we need to know. Correct? So first we'll calculate what are the number of moles of HCl we have and NaOH we have. Okay? So number of moles of HCl is equal to molarity into volume in liters. So molarity is 0.1, volume is 0.5 in liters. So it will be 0.05. Then we are calculating the number of moles of NaOH, which is nothing but again molarity into volume. So molarity is 0.2 and volume is 0.2. So this is 0.04. So NaOH is the limiting reagent as it is less and it will be completely utilized. So 0.04 moles of NaOH will be neutralizing 0.04 moles of HCl. Some excess amount of HCl will be remaining. But we know that for 1 mole, heat evolved is 57.3 kilojoules. Thus, for 0.04 moles, how much heat? So, we have to just multiply 0.04 into 57.3 kilojoules. Kilo, I'll keep it as it is, as my answers all are in kilo. So, this will be 2.292 kilojoules. So, which is the correct option? Option B. Okay. So, we'll see the next question. During the adsorption of krypton on activated charcoal at low temperature, delta H is less than 0, delta S is less than 0, delta H is greater than 0, delta S is less than 0. Option C, delta H is less than 0 and delta S is greater than 0. Option D, both delta H and delta S are greater than 0. First of all, adsorption process, delta H is negative and krypton is a gas which is getting adsorbed on the activated charcoal. Randomness is decreasing. So what happens? Delta S also is negative. So both delta H and delta S should be less than 0, isn't it? So delta H and delta S is less than 0. Option A is right answer. Okay. We'll go to the next question. The set of quantum numbers for the outermost electron in copper in its ground state is. So, we'll right away write it instead of just looking into the options. For copper, electronic configuration is argon 3d10 4s1. So, this is the outermost shell. So, N value is 4, L is 0 because it is S, and when L is 0, M also is 0. And S will be plus or minus half. So 400 half. 4000 half. That is option D is the right answer. Okay. Next question. Peroxide ion is diamagnetic, has 5 complete filled or antibonding molecular orbitals, is isoelectronic with neon, has bond order 1. Which of this is correct? So out of this we have to see which is correct and then we have to choose the correct answer. So I'll not see the options. I'll see which statement of these are correct. So what is peroxide ion? It is O2 2 minus. How many electrons are there? So number of electrons in this is 18. And if there are 18 electrons, what is the bond order will be equal to 1. Okay. How? I hope you know this. I have done it several times. If there are 14 electrons, bond order is 3. If it is 16 electrons and it is 12 electrons, bond order is 2. That is, I have increased 2 and decreased 2. Then if it is 10 electrons, bond order is 1. And here if it is 18 electrons, bond order is 1. And some between numbers you have to 0.5 you have to put. Okay. So 18 electrons it is there. So bond order is 1. So this is right. Is isoelectronic with neon? Is wrong. Neon has got 10 electrons, but here we have 18 electrons, isn't it? It is diamagnetic. Yes, it is right, because oxygen is paramagnetic. We know that pi star 2p, y and x has got 1 electron each, that is in the antibonding orbital. So 2 more extra electron andre allella pair agirutte, so it will be diamagnetic. Just remember or recall the molecular orbital theory and the diagram. You will get it very clearly. Now, what about option B? Has 5 completely filled antibonding molecular orbitals. How is it 5? It is not 5. See, you have sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. After this, you have sigma 2p z2. Then you have pi 2p x2, pi 2p y2, which are equal to one another. After this, you have pi star 2p x1, which is equal to pi star 2p y1. Correct? No? This is for oxygen I am talking about. 2, 4, 6, 8, 10, 12, 14, 15, 16. Now when there is 2 more extra electron of peroxide, first this will be filled. So this will be 2, this will be 2. So it's diamagnetic, and if I count the antibonding molecular orbital, you can see 1, 2, 3, 4, and these are degenerate as well. So is it 5? No. So this is wrong. So which are the 2 options which is right? Statement A and D. So you have to look into the option which contains A and D, and option C is A and D, which is absolutely right. So we shall move into the next question. Which one of these is not true for benzene? Okay. Option A, there are 3 carbon-carbon single bonds and 3 carbon-carbon double bonds. This is wrong. Why? Because there is delocalization of pi electrons. We cannot count that 3 single bonds and 3 double bonds, and the bond order also will come 1.33 if we calculate, isn't it? So that is the one which is not true. We'll see whether the others are right. Option B, it forms only one type of monosubstituted product. It's right. The bond angle between the carbon-carbon bond is 120 degree. Even that is right. The heat of hydrogenation of benzene is less than the theoretical value. This also is absolutely right. So which is not correct is option A. Okay. So option A is the correct answer for this particular question, because they are asking which is not correct or which is not true. Okay. 14th question. The mixture of calcium chloride and sodium chloride weighs 4.44 grams is treated with sodium carbonate solution to precipitate all the calcium chloride ions as calcium carbonate. The calcium carbonate so obtained is heated strongly to get 0.56 grams of calcium oxide. The percentage of sodium chloride in the mixture is what? So we have to find out the percentage of sodium chloride in the mixture of calcium chloride with sodium chloride. So what they are doing is, calcium chloride is first treated with sodium carbonate to precipitate calcium carbonate, and 2 NaCl is formed. So this is completely precipitated. So it is taken out, filtered, and then calcium carbonate was heated, okay, to form calcium oxide, and carbon dioxide gas is liberated. Now, if we observe this equation, what we understand is, when I take 1 mole of calcium chloride, I get 1 mole of calcium carbonate. So 1 mole of calcium carbonate gives 1 mole of calcium oxide. So I can tell directly that from if I have 1 mole of calcium chloride, I'll get 1 mole of calcium oxide. Correct? Yes. So how much grams of calcium oxide I have? 0.56 grams I have. So 1 mole of calcium chloride will give me 1 mole of calcium oxide, and calcium oxide I have 0.56 grams. Okay. So what is the number of moles? Mass by molecular mass. This is 56. 40 plus 16 is 56. So 0.56 divided by 56 is what? Is 0.01 moles. So if 0.01 moles of calcium oxide I have, then 0.01 moles of calcium chloride also I should have. So what is the number of moles of calcium chloride? Number of moles of calcium chloride is 0.01. Correct? Now, what is the mass I will find out? Mass of calcium chloride. Number of moles into molecular mass. Molecular mass is 40 plus 71. What is that? It is 111 grams. So this will be equal to 1.11 grams. Therefore, NaCl plus CaCl2 is equal to 4.44 grams. So NaCl is 4.44 minus 1.11, which is 3.33 grams. Correct? So percentage of NaCl is 3.33 grams out of 4.44 grams is present. Into 100 if I do, I will get it as 75%. And the answer is option B, which is 75%. Correct? Yes. So, shall we move on to the next question? Question number 15. 1 mole of an ideal gas increasing the temperature from 10 degree to 20 degree Celsius increases the RMS velocity by root 2 times, increases the average kinetic energy by 2 times, or option C, increases both average kinetic energy and RMS velocity but not significantly, increases the RMS velocity by 2 times. So, what is that we need to find out? When the temperature was changed from 10 degrees Celsius to 20 degrees Celsius, how exactly it affected the average kinetic energy and the RMS velocity. So, the formula of average kinetic energy, average kinetic energy is 3 by 2 RT. So, I'll take it as kinetic energy 1 and kinetic energy 2. 3 by 2 and 3 by 2 will get cancelled. R and R gets cancelled. Temperature is 283 Kelvin and 293 Kelvin. That is 10 degrees Celsius and 20 degrees Celsius have converted. So, this if I calculate, I'll get it as 0.96. Okay. Now, if I take the RMS velocity, VRMS velocity is square root of 3 RT by M. So, from this I can make out it is square root of T1 by T2, which I can take if I take the ratio of RMS velocity 1 divided by RMS velocity 2, that is square root of T1, that is 283 divided by 293. Correct? So, this is nothing but square root of 0.96, which you will get it as 0.979 something or 978. But is it increasing? Yes, it is increasing, but not significantly, not 2 times, not square root 2 times, isn't it? So, option A, increases RMS velocity by square root 2 times, it's wrong. Increases the average kinetic energy by 2 times is wrong. Increases the RMS velocity by 2 times also is wrong. It increases but not significantly. Option C is the correct answer. Okay. 16th question. Generally, the first ionization energy increases along a period, but there are some exceptions. One which is not an exception is sodium and magnesium, nitrogen and oxygen, beryllium and boron, magnesium and aluminium. So, they are asking which is not an exception while the ionization enthalpy is increasing along the period. Along the period when it increases, there are some exceptions when completely filled orbitals or half filled orbitals are coming, isn't it? Or the size of the atom is varying. There are some exceptions which is there. So, which is not an exception they are asking. Nitrogen and oxygen is an exception. Beryllium and boron also is an exception. Magnesium and aluminium is also an exception. The one which is not an exception is sodium and magnesium. Sodium and magnesium is not an exception at all. Okay, it is correct. It is following the trend. Thus, it is sodium and magnesium which is the correct answer. Okay, next question. 50 cm cube of 0.2 normal HCl is titrated against 0.1 normal NaOH. The titration is discontinued after adding 50 cm cube of NaOH. The remaining titration is completed by adding 0.5 normal KOH. The volume of KOH required for completing the titration is 10 cm cube, 12 cm cube, 10.5 cm cube or 25 cm cube. So, what we have taken is, we have taken 50 cm cube and 0.2 normal HCl, and for this the titration is done with 0.1 normal NaOH. Okay, and after adding 50 cm cube of NaOH was over and the titration was discontinued. That means the end point has not yet come. Then the remaining solution out of this 50 cm cube, some amount got neutralized with NaOH solution. Okay, but there is some more amount of HCl which is not yet reacted. or it is not yet neutralized. So next what they used 0.5 normal KOH for the titration. So what is the volume of KOH which is used for or required for completion of the titration is the question. So I'll take this as N1V1 is equal to N2V2. So here this is for NaOH and this is for HCl. So HCl normality is 0.2, but I don't know the volume which got neutralized. But NaOH I know 0.1 normal and full 50 cm cube was added for titration. So I will find out V1. V1 is 0.1 into 50 divided by 0.2. So it is 25 cm cube which is not yet neutralized or it is remaining out of 50. Okay. Now I will use again N1V1 is equal to N2V2. Now what I will use, this is for HCl and this I will use for KOH. So HCl, how much is remaining volume? 25, which is not yet reacted, and the normality of this is 0.2. So 0.2 into 25 is equal to normality of KOH is 0.5. Volume I need to find out. Correct? So V2 is equal to 0.2 into 25 divided by 0.5. So it is 10 cm cube. Answer is option A, which is 10 cm cube. Question number 18. In which one of the following does the given amount of chlorine exert the least pressure in a vessel of a capacity 1 dm cube and 273 Kelvin? A. 0.071 grams, 0.0355 grams, 0.02 mole or 6.023 into 10 power 21 molecules. So, what do you need to find out? Which one of them, okay, which is the mass of the gas is going to exert least pressure is what you need to find out. Okay, we know that PV is equal to nRT and volume R and T are constant here. So P is directly proportional to the number of moles. So option A, number of moles in 0.071 grams. I just have to divide by the mass by molecular mass. Molecular mass is 35.5. So this will be 2 into 10 power minus 3. Option B, 0.0355 divided by 35.5. So move 3 points. So 1 into 10 to the power minus 3. Option C, it is directly given 0.02 moles. Option D, they have given the molecules. So for number of moles, it is 6.023 into 10 power 21 divided by Avogadro number 6.023 into 10 power 23. This is again 0.01. Correct? So which is having the least number of moles? It is option B. So option B is the one which will exert least pressure. Got it? So I hope you have understood. We'll go to the next question. Based on first law of thermodynamics, which one of the following is correct? For an adiabatic process, delta U is equal to minus W. For an isochoric process, delta U is equal to minus Q. Option C, for a cyclic process, Q is equal to minus W. For an isothermal process, Q is equal to plus W. Here, which one of the following is correct based on first law of thermodynamics? It is a fact which you need to know. Option C is correct. That is, for a cyclic process, Q is equal to minus W. That is the correct one. Okay. We'll see the next question. For alkali metals, which one of the following trend is incorrect? Ionization enthalpy, as we come down the group, ionization enthalpy decreases, isn't it? So the highest is for lithium, that is right. Hydration energy, again based on the size of the ion, smallest is Li plus. So of course the hydration energy is highest for that. So option B also is right. Atomic size, it is right. Of course option D should be the wrong one because all the other three are correct. We'll see here. density, lithium, sodium, potassium, rubidium is given. Here is the change. It is lithium, potassium, sodium and rubidium. Potassium is lighter than sodium. Why? Because there is a sudden increase in the size, and we know that density is mass by volume. Volume suddenly increases, so density will decrease. So, of course, option D is the one which is wrong. Okay. So, I hope you have understood the part A of Karnataka CET 2010 question paper. Stay tuned for part B. Thank you, my dear children.